Welcome. The Office of the Chief Data Officer and the Texas Department of Information Resources are pleased to offer this course, Introduction to Charts and Graphs. In this course, we will discuss the difference between charts and graphs, some of the most used charts and graphs and when to use them, and some best practices in designing data visualizations. Data visualization is the presentation of data and information in a structured format that organizes, simplifies, and clarifies data. Data can be visualized through the use of data tables, charts and graphs, or even maps. The format you choose to use depends on the nature of the data, the questions you are trying to answer, and the needs of your audience. But what are the benefits of using charts and graphs to visualize data? Charts and graphs allow users to see important highlights at a glance, rather than having to sift through many columns and rows of data, and they are useful for revealing patterns and relationships within the data. Your audience or customer might want charts and graphs so they can quickly make multiple comparisons, easily see relationships between variables, or look at trends over time and how close their program is to achieving desired goals or outcomes. There are many options to choose from when using charts and graphs to tell a data story, but different types of data visualizations are best for different purposes. Some charts are best suited for comparing information grouped into discrete categories. Other charts are best suited for comparing numbers that can be counted or measured. Some charts display trends while others display distributions. Some charts might display a single number, while other charts are best suited for displaying both categorical and numeric data together. Some charts and graphs are simple and straightforward, while others are more complicated. Because there are many options to choose from, understanding the audience's needs and goals, as well as the depth of their statistical knowledge, is also a deciding factor in which format of visualization is most appropriate to use. Before we discuss different types of charts and graphs and when you might use them, we should first address the differences between them. Charts and graphs are both visual representations of data, but they differ in their presentation style and purpose. You may hear the words chart and graph used interchangeably, but charts and graphs are not always the same thing. At a high level, all charts and graphs fall under the general category of chart. In other words, graphs may be considered a type of chart, but not all charts are graphs. Charts are often used with simple datasets to display groups or categories in a structured and organized manner using bars, lines, or pie slices to show relationships or make comparisons between the different categories. Graphs, on the other hand, can be used to represent more complex datasets in a visual format, often using lines or points placed on both an x and a y-axis. Graphs typically show relationships between numeric variables that can be counted or measured, rather than discrete categories. Graphs are good for presenting trends, distributions, and correlations. Charts highlight the different parts of the data, while graphs show the connection between the numbers. Charts can provide a broad summary of the data, focusing on the main points, while graphs can provide more in-depth views into data behavior. There are many options to choose from when using charts and graphs to tell your data story, but different types of data visualizations are best for different purposes. Your audience may be interested in what happens over time, want to examine relationships or see the distribution of the data between categories, or they may simply want to make part-to-whole comparisons. Knowing the questions your audience needs to answer will help you narrow down your choices. Part-to-whole charts are best when the audience needs to see how each part of the data or group compares to the whole or total. Part-to-whole charts allow the audience to compare the proportions of distinct groups of categorical data to the total. A benefit of part-to-whole charts is they allow your audience to see at a glance which group is represented the most, or if certain groups are similar to each other. Part-to-whole comparisons are useful if your audience is interested in information such as which service category within a program is utilized the most, or utilized the least, or which department within the organization has the highest proportion of vacancies. One chart commonly used to make part-to-whole comparisons between groups or categories is the pie chart. In a pie chart, each slice of the pie represents a group, and the size of each slice represents the proportion of that group compared to the whole. Pie charts often display the percentage for each slice, and the total of all the slices equals 100%. For example, you may choose a pie chart if you want to know the proportion of snacks served by Child and Adult Care Food Program (CACFP) daycare home providers compared to all meal types served. Visualizing the data in a pie chart quickly shows that snacks are served more often compared to the other types of meals and account for more than 1/3 of the total meals served by this provider type. Donut charts are a variation of pie charts, but they have a hole in the center. The hole in a donut chart adds white space, which can reduce visual clutter and contribute to a better understanding of the proportions. Pie and donut charts are most effective when there is a small number of groups to compare. Too many slices decrease the impact of the visualization because it can be difficult to see the differences between small or similar values. If you have a large number of groups, you may consider combining the smaller values into an other category, but make sure doing so doesn't hide interesting information. Tree maps visualize the data as a set of nested rectangles where each group is represented by a rectangle, and the size of the rectangle is proportional to its value. Tree maps are a good option when you want to make part-to-whole comparisons, but there are too many groups in the category for a pie or donut chart. If you want to compare the parts of a category over a second dimension, such as time, 100% stacked bar and column charts are an option. For example, let's say you want to compare the proportion of views and downloads for data published on the Texas Open Data Portal for different time periods. A 100% stacked column chart allows you to compare the proportion of visits to downloads both within and between each time period. If your second dimension is time, the time periods should be placed on the horizontal x-axis and ordered so time runs from left to right. The percentages can be displayed along the vertical y-axis. However, like pie and donut charts, their use should be limited to when you have relatively few categories to avoid visual clutter and hard-to-read charts. We will go into more detail about other kinds of bar and column charts later in this course. Part-to-whole charts, like pie charts and tree maps, are great for making comparisons. But there are a few things to consider that will help your audience accurately read and understand the data presented. Because these charts make part-to-whole comparisons, the values of all the slices or rectangles should add up to 100%, and they should be sized proportionately to their corresponding value. If the value of the slices adds up to more than 100% due to rounded data, include a note within the chart with an explanation. Part-to-whole charts should be displayed in descending order. Pie charts are best displayed with the largest slice starting at 12 o'clock and arranged in either a clockwise or a counterclockwise direction. While either direction is valid, be consistent across all your pie charts. Tree maps should be arranged so the largest rectangle is at the top left and the smallest rectangle is at the bottom right. Avoid using multiple pie charts within one visualization to make comparisons, because the proportional sizes of the slices can be difficult to compare across pie charts. Consider using a 100% stacked bar or column chart instead. Pie charts and tree maps are good options when you want to compare the proportions of groups within a categorical variable. However, there are other visualization options to consider if you want to compare numeric values between variables to examine relationships. Bar and column charts are often used to visualize the relationship between a categorical variable and a numeric variable. In this type of chart, each bar represents a member of the category, and the length of each bar represents a numeric value. For example, you might want to visualize the number of employees in each department within your organization. You could use a pie chart to show the proportions, but a bar chart is a better option when there are many groups within the category and the value of the numbers is more important than the proportions. Bar charts and column charts are essentially the same, except that bars are oriented horizontally and columns are oriented vertically. If the group labels are long, a bar chart is a better choice since the labels require more horizontal reading space. Diagonal or vertical labels used in column charts can be difficult to read if you have longer labels. Bar charts are also a better option when there are a large number of groups, so the labels aren't obscured and hard to read. Lollipop charts are a variation of bar and column charts. In this type of chart, The bars or columns are replaced with a line segment with a dot at the end. Lollipop charts are visually less cluttered than bar and column charts and may make it easier to see the differences between groups when the values are close. Earlier, we talked about using 100% stacked bar and column charts to visualize part-to-whole proportions when there is more than one variable. If you want to visualize and compare numeric values instead of proportions, a regular stacked bar or column chart is a good option. In a regular stacked bar or column chart, the entire length of the bar represents the total number, and the different shaded areas within each bar represent the totals of the separate components of the category. If there are too many components or groups within the category, stacked charts may become too cluttered and hard to read. In these cases, consider using a grouped bar or column chart. In this grouped column chart, the number of views for each data literacy video is grouped and displayed by month. The number of views is displayed on the vertical y-axis. Months are placed on the horizontal x-axis and ordered so time runs from left to right. Each column represents a data literacy video, and the length of the column is relative to the number of views. A legend or key is included to define what each column represents. Bar and column charts are among the most popular formats for visualizing data in a clear and concise way. However, there are a few best practices to consider when designing your bar and column charts to help your audience understand the information presented. Bar and column charts use length and height to represent values proportionally. So, a bar twice the length or height of another bar represents twice the value of that other bar. Therefore, the axis displaying the values should start at 0 or 0 baseline to avoid distortion. Starting the baseline at a number other than 0 can distort the perspective, causing differences to appear larger than they are and lead your audience to draw the wrong conclusion. Space the distance between the bars or columns within the chart far enough apart so it is obvious they are separate categories, but close enough to each other to make comparisons between the categories easier. A good practice is to set the space between bars to half the width of the bar. For example, if you set your bars to be 10 pixels wide, set the space between the bars to 5 pixels wide. Be careful not to obscure labels, especially in column charts. Use your best judgment when determining the best spacing to use. Order the data displayed in the bar or column chart in a logical format. The data can be displayed alphabetically, by values such as ranked order, or sequentially if your values represent time. The order you choose depends on the data, the question you are trying to answer, and the needs of your audience. In bar and column charts without multiple groupings, it is generally best to use one solid color for the bars and columns. Using many colors or textures within one chart can create visual clutter and distract from the main point you want to convey. However, it may be appropriate at times to use a high-contrasting accent color to highlight a significant data point. With stacked or grouped bar charts, colors or textures are necessary to keep the category components obviously separate from each other. Be consistent in your choices across all the charts you provide in your reports and dashboards. Choose colors and textures that have a high degree of contrast so the components are visually distinct and your chart meets accessibility requirements. You can find information on accessibility tools and resources on the Texas Department of Information Resources website. While bar and column charts visualize the relationship between a categorical variable and a numeric variable, scatterplots are often used to visualize the relationship between two numeric variables. In a scatterplot, the x-axis represents the unit of measurement for one variable, while the y-axis represents the unit of measurement for the other variable. Each dot on the graph represents an individual data point. Scatterplots are often used to determine if there may be a linear relationship or correlation between the two variables. Let's say you want to examine the relationship between two different types of meals served by providers in the child and adult care food program. In this scatterplot example, each dot represents the number of meals served by a given provider, with the number of breakfasts on the horizontal x-axis and the number of lunches on the vertical y-axis. The overall dot pattern illustrates a relationship between these two meal types. Providers who serve more breakfasts tend to also serve more lunches. In a scatterplot, you can also include a categorical variable, such as type of provider, where the colors of the dots represent the different groups within the category. If you want to include a third numeric variable instead of a categorical variable, a bubble plot is an appropriate option. Bubble plots are similar to scatter plots, but in a bubble plot, the value of the third numeric variable is represented through the size of the dots. Include a legend defining the third variable, whether categorical or numeric, to ensure your audience can interpret the data correctly. Keep in mind, adding a third variable to a scatter or bubble plot can make individual differences hard to see. Use your best judgment as to whether including a third variable within one visualization is an optimal choice. Often, splitting the data into two separate visualizations can make relationships easier to detect. Scatter plots and bubble plots are best for smaller datasets. When your dataset is large, the dots will tend to overlap, making the data hard to read. This is called overplotting. If you must use a scatter or bubble plot to visualize the data, there are a few things you can do to try to fix this. For example, you can adjust the dot size, add transparency to the dots, or visualize a sample of the data rather than the entire dataset. Adding an interactive feature where additional information is presented in a flyout box when hovered over can also help the audience better understand the visualization when the dataset is large. Presenting the data in multiple, separate visualizations is also an appropriate option. Sometimes your audience needs to know how something changes or trends across a continuous variable, such as time or distance. In these cases, you can display information using line graphs and area charts. Line graphs are a common format of visualization used to display numeric data that changes in order or quantity. They are most often used to show change over time and are helpful for forecasting or predicting trends. In a line graph for visualizing change over time, the unit of time is displayed on the horizontal x-axis and the unit of measurement is displayed on the vertical y-axis. Line graphs may be simple, displaying only one line to represent the relationship between two variables over time, such as the number of video views by month for a data literacy video on data governance. Line graphs may also be complex, displaying multiple lines when there is more than one group, such as the number of video views by month for different data literacy videos. You can use different line widths and types to help the audience better differentiate the lines. Line graphs aren't only used for visualizing data over time. Other continuous variables, such as age and distance, can be visualized with line graphs as well. There are a few best practices to consider when using line graphs to visualize the data. For instance, the zero baseline rule used for bar and column charts does not apply to line graphs. In other words, the y-axis does not always need to start at a baseline of 0. There may be small changes in the data that are meaningful, and you can call attention to those changes by shortening the scale and starting your axis at a number other than 0. That being said, it is still a good practice to start line graph axes at 0 whenever possible to avoid distortion of perspective. If your axis baseline starts at a number other than 0, make sure the audience is aware. Include a note with your graph that describes where the graph's baseline starts and why you chose to display the data in that way. Additionally, when you have multiple groups or categories to display in your line graph, use varying line widths and types that are easily distinguishable from each other to avoid confusion. Solid lines are easier to read than dashed and dotted lines, so use solid lines whenever possible. Label the lines directly if it doesn't introduce too much clutter, or provide a key or legend to indicate what each line style means. Furthermore, line graphs are best when there are a limited number of categories or groups in the data, because too many lines can obscure the information. If the lines in your graph are not easily distinguishable from each other due to a large number of categories, consider using a different type of visualization, such as a grouped column chart. Finally, pay attention to the aspect ratio of the axes, or the graph's height to width ratio. The aspect ratio can be manipulated to make patterns in the data more or less apparent. Choose an aspect ratio that makes important differences noticeable in the visualization without exaggerating those differences. Exercise caution, because you may give the wrong impression and mislead your audience. An area chart is a variation on the line graph. In an area chart, the section below the line is filled in to make the pattern of change more obvious. Just as with a line graph, height on the y-axis is not summed across groups. So in this example, If views for data privacy were higher than views for data governance at one time point, we would not be able to see the exact number of views for data governance at that time point. When you have multiple groups or categories that change over time, a stacked area chart or compound line graph is a good option to show the changes in composition over time for each category, as well as part-to-whole proportions. In a stacked area chart, the total y-axis height is the sum for all groups or categories at a given point on the x-axis. Area and stacked area charts are best when you have a small number of categories to visualize. Visualizing data with many categories can become cluttered, and the information you are trying to convey can get lost. If data results in crossing lines on a line graph, a basic area chart cannot provide a complete visualization of every category across time. In these cases, consider using a stacked area chart, a different kind of graph, or even displaying the data in two different charts or graphs. There are often times when your audience needs to see how numerical data is distributed over a continuous measure, such as age in years, budget in dollars, or height in inches. When you need to visualize this type of information, histograms and box plots are good options to choose from. Histograms are a common way to show the distribution of one or more numeric variables over a continuum. Instead of presenting the numeric variable continuously, like in a line graph, the data is grouped into intervals or bins such as an age range. The number of observations within each interval is represented by the height of the bar. For example, you can use a histogram to show the incarcerated inmate population in Bexar County by age group. In this histogram, each bin represents an age group, and the height of the bars represents the population of inmates in that age group. As another example, you can use a histogram to show how much the Bastrop Economic Development Corporation spent on job training from fiscal years 2016 to 2023. Each bin represents a fiscal year, and the height of the bar represents the money spent on job training for each year. In practice, histogram x-axes are labeled in a few different ways. Sometimes the labels show the bin boundaries or cut points. Sometimes they show each bin's full range of values. And sometimes they mark the midpoint of each bin. All of these are ways to label intervals on a continuous scale. Regardless of the labeling style, it should be clear what numeric interval each bar represents. Notice that in this example, labeling each bin with its corresponding age range seems to be the most effective choice out of the three options. Histograms may look like column charts, but they are not the same. A histogram represents the distribution of a numeric variable, such as the Bastrop Economic Development Corporation's job training expenditures, across an interval, such as fiscal years. A column chart shows the relationships between distinct categories or groups, such as the number of employees by department. There is little to no space between the bins in a histogram because the horizontal x-axis represents a continuous range of values, rather than discrete categories. You can adjust the width of the bins to find the most appropriate display of the data for the information you want to convey. For example, when visualizing data over time in a histogram, you might choose the bins to represent weeks, months, or years. Smaller bins, such as presenting the data in weeks, may create a graph that is overly busy or cluttered, while larger bins, such as presenting the data in years, could hide or obscure interesting patterns in the data. The most appropriate width of the bins will depend on the range of the continuum and the questions your audience needs to answer. If your audience wants to compare the distribution of data for two different groups, such as examining the number of traffic fatalities by age and sex, you can visualize the data using one histogram. However, using one histogram to visualize the data can sometimes make it difficult to interpret the data accurately. For example, in this histogram, your audience may incorrectly interpret the data to mean females have many more traffic fatalities than males. Further, it is difficult to compare the distribution of fatalities among women across age groups because the bins for that group don't start at the same baseline. A mirror histogram plots the data for two different groups in a way that makes it easier to compare their distributions across all bins. In a mirror histogram, the baseline is displayed on a vertical axis in the center of the graph, with one group laid out to the left of the axis and the other group laid out to the right of the axis. Visualizing the data in this way makes it more obvious that females do not appear to have many more traffic fatalities than males. Between the two groups, males appear to have more traffic fatalities at a younger age, and females appear to have more traffic fatalities at an older age. When plotting the distribution of age in this format, the chart is sometimes referred to as an age pyramid. Histograms should be limited to a small number of groups for comparison, because visualizing 3 or more groups in one graph can make it cluttered and hard to read. If you want to compare the distributions of more than 2 groups, consider using a bar chart, line graph, or breaking the information up into more than one graph. Another option for visualizing the distribution of numeric variables is the box plot. Box plots can be used to show the distribution of up to 4 or 5 numeric variables, but this type of graph contains more statistical information than histograms, such as the median value, quartiles, the interquartile range, and any outliers. These additional elements increase the complexity of the visualization, and the use of box plots should be reserved for audiences who require the additional information box plots provide. Box plots should be limited to a small number of variables for comparison. Visualizing more than 4 or 5 variables can make the graph cluttered and hard to read. Furthermore, box plots do not provide information such as the total number of observations or the distributions of individual data points. If this information is required, you can add a jitter element to visualize the individual data points. However, this additional element can introduce clutter and make the visualization difficult to read. There will be times when your audience simply needs to know a single number. While other kinds of charts can meet that need, data visualization cards, gauge charts, and tables can provide those single numbers in a quick, simple, and effective way. Data visualization cards often present single numbers in a dashboard alongside other data visualizations. This type of visualization is useful when you want to provide context for other visualizations. It is also useful when you want to highlight specific or critical data points, such as key performance indicators. Each card includes a title to describe what the number represents and may also include other information such as a date range or the data source. Gauge charts look a little like a fuel gauge in a car, and like data visualization cards, are often presented in a dashboard to highlight single metrics or provide overall information at a glance. This type of visualization is often used to display measures of performance or efficiency because they can tell the audience how far away something is from the target or goal. Finally, tables are a powerful way to summarize data in a visual format. Tables are useful if your audience needs to examine individual values, such as totals, and they also allow the audience to compare multiple values within the same dataset. You can learn more about visualizing data with tables in the Texas Data Literacy Program course, Data Visualization with Tables. In this course, we've already addressed a few best practices associated with particular charts and graphs. However, there are other, more general best practices that apply, regardless of which chart or graph you use. First and foremost, it is important to know your audience before designing your data visualizations. Understanding the audience's needs and goals, as well as their data expertise, will help you determine which format of visualization is most appropriate to use. In most cases, it is best to choose the simplest format of visualization that still provides the relevant information. Every data visualization needs a title to distinguish it from other visualizations your audience might use. Titles set the stage and tell the audience what information they should expect to see in the visualization. Therefore, titles are placed at the top of each chart or graph so they are read first, and titles should be descriptive enough to clearly convey what the visualization represents. If the title is long, consider adding a subtitle to provide additional information. Include titles or labels on the horizontal and vertical axes to define the scale and units of measurement. Titles on each axis of a visualization should be clear and concise, yet provide meaningful descriptions. For example, rather than using an axis title of age, a more descriptive title might be Inmate Age Group. Data labels provide context that isn't part of the title, subtitle, or axis titles, and they are included directly within the chart itself. For example, you might label the individual lines in a line graph. However, use data labels sparingly to avoid cluttering and obscuring the data. If you include labels for data points within your visualizations, Avoid showing decimals or being overly precise in those labels whenever possible. Being overly precise can obscure trends or create clutter in your dashboard. In cases where decimal points are necessary, where the number is less than 0, for example, limit the data label to 1 decimal point if possible. Or include interactive flyout boxes that provide detailed information when hovered over. Legends also provide additional context and may be a better option than data labels. Legends show the symbology used in the chart, such as colors and shapes, and define the meaning or the values they represent. Legends are typically situated at the bottom or on the side of the visualization. Include notes, sources, and credits at the bottom of your charts and graphs to provide even more context, such as where the data came from, how it was processed and analyzed, definitions of displayed units of measurement, and who contributed to the data. Charts and graphs should be simple, easy to understand, and clearly show the main points. Evaluate your visualizations to determine whether each element provides only necessary information, including titles, labels, and data points. Extra design elements that don't add meaningful information, such as three-dimensional perspectives, shadows, and dark backgrounds, are often called chart junk. These unnecessary elements can distract your audience and reduce the readability and comprehension of the visualization. Similarly, use borders and lines sparingly to reduce visual clutter. Grid lines in a chart or graph can help the audience discern specific data values and make comparisons easier. However, heavy borders and grid lines can add visual clutter and compete with the data itself. Use smaller width lines that contribute to the interpretation of the data, rather than detract from it. Finally, make sure your charts and graphs adhere to accessibility requirements. For example, include text descriptions of the visualizations and include a table of the data when possible. Use color combinations that provide a high degree of color contrast, and choose sans serif fonts to ensure readability. Your organization may have standard colors, fonts, and sizes as part of brand requirements, which may have been chosen to meet accessibility requirements. You can find more information on accessibility tools and resources on the Texas Department of Information Resources website. Charts and graphs are a powerful way to present highlights at a glance and for revealing patterns and relationships within the data, but different types of data visualizations are best for different purposes. Your audience may be interested in what happens over time, want to examine relationships or see the distribution of the data between categories, or they may simply want to make part-to-whole comparisons. The format you choose to use depends on the nature of the data, the questions you are trying to answer, and the needs of your audience. You have now completed the course, Introduction to Charts and Graphs. In this course, we talked about the difference between charts and graphs, some of the most used charts and graphs, and some best practices in designing data visualizations. For more information on the Texas Data Management Program, visit the Office of the Chief Data Officer website.